Hello, everyone. My name is Ali Bizel, and I'm the Director of Developer Marketing here at Census. We are doing a remote session for Sarah Krasnik this morning since she wasn't able to make it live, but we have a great recording from her. And she will be discussing delivering value as a data engineer. Sarah is currently working as a freelancer, as a contractor and consultant for data engineering, as well as working on her own project, Versionable, which she talks a little bit about at the end. She was formerly a lead data engineer for Perpay. You've probably seen her on the Census blog if you've read it and around the internet. And with that, I will turn it over to Virtual Sarah, and I'll see you all at the end for a little bit of messaging about how to answer questions or ask questions to Sarah. Thanks.
Thank you for coming in to listen to my talk at Summer Community Days. I'll be talking about really what data engineering is and how it can be valuable to the organization at large. But first, a little about me. I'm Sarah. I previously led data engineering and analytics teams across several industries, including IoT and most recently fintech. Now I'm consulting other companies doing the exact same thing, advising data companies themselves, and even building out a potential piece of the tech stack. But if you'd like to chat more about that, find me after the talk or check out versionable.io. I'm segmenting this particular presentation into two parts. First, defining not only what data engineering is, but what engineering more broadly is, especially in the context of analytics teams. Next, I'll be diving into really what the meat is of why you should care about engineering principles across both analytics and even operational teams. More specifically, how data engineering contributes to organizational growth at large and high-level metrics. With that, let's dive in. In the world of data, there are plenty of titles to go around: data scientist, analyst, machine learning engineer, research analyst, and of course, what we're talking about today, the data engineer. I'm going to talk about how all of these titles overlap and differences among all of them. But first, let's talk about electricity. We're all benefiting from it, but you probably didn't think of it until now, or maybe you did if you had some, Wi-Fi issues connecting to the conference. I'm personally living in Philly, where we have Pico. We only think of these companies when either we move and need to register a new address, or when there's a huge thunderstorm that takes down trees, which might cause a power outage. Then we scramble, phone lines go crazy and have crazy wait times, to the point where we all have faith someone's got it under control and it's not even really worth calling anymore. We wish we had an alternative, or maybe go digging deep in the camping gear to bring out the small power station to charge devices. Some of you may have experienced the same feeling during the Snowflake outage a few months ago, or the AWS outage a couple months before that. There just wasn't really a Snowflake camping alternative that's easy to plug in as a backup. The analogy I'm really trying to draw here is in comparing electricians to data engineers. When everything is working just fine, you kind of forget they're there. And that's a good thing. That's their job, to keep everything working just fine. Now, staying on the topic of electricity, but now focusing a little more on batteries. I think we can all agree that building a battery-powered circuit to understand the physics of electricity is fundamentally different from building a waterproof battery-powered watch. Underneath, the fundamentals are exactly the same. Batteries are batteries. When building an at-home circuit, you don't need to concern yourself with how much space it takes up, putting it in waterproof casing, the weight of it all, and more. These are all practical logistics to make it more useful and efficient. In a data scientist case, building a machine learning model on a local computer is like building an at-home circuit. You need to understand how it works, validate it works in different scenarios, and be sure it solves the problem that you're ultimately trying to answer. You don't need to be as concerned with how much memory it takes on your computer or how much time it takes to train and predict the model. If this model is to run in real time on an IoT device, maybe this data scientist works for Nest and automatically adjusts the optimal time it starts to heat the house before you come home from work, which might vary day to day. Hardware is important, so we have to consider memory and storage. It has to be able to run on such a small device. But an important note here: sometimes the at-home solution is only what you need. The key here is assessing when do you need a waterproof solution that adds so much complexity? What's the market, the business case, and who's the audience? When do you need to be concerned about hardware? I guarantee you Apple and Fitbit didn't start development with a waterproof watch. There were likely many different proofs of concepts that were complicated, involved a lot of different people testing, etc. They probably did some market valuation and came up with the minimal viable product that would sell. When it comes to data as the product, this trade-off of analysis versus systems thinking is what not only differentiates data engineers from analysts and scientists, but also what differentiates data engineers from software engineers. So where do these other titles like data analyst or data scientist come in when it concerns analytics teams? The most prominent titles you've heard, besides the data engineer title we're talking about today, is data analyst and data scientist. They're not totally dissimilar and actually work quite closely with one another. Let's start with the data analyst. This person is the closest to the other parts of the business out of all three of these roles. They are very, very intimately aware of the questions that data stakeholders want to answer, whether it be gaining an understanding of different types of marketing or sales techniques or diving into different accounting models. The analyst bridges the gap between data and answering business questions. With that, they work closely with stakeholders and are business adjacent, are usually comfortable with SQL, but focus on visualizing data or doing one-off analyses for stakeholders themselves to actually make decisions upon. Let's move to the data scientist. This role really started getting popularity about 10 years ago. This person's background is in statistics and can code as well. Their place in the organization isn't as business forward as the data analyst. They do a lot of ad hoc analyses and proofs of concepts of different modeling techniques. They need to be business adjacent enough to understand the questions they're trying to answer, but their mastery is really in statistical modeling when simple case statements just aren't enough, or even in machine learning if you take it one step further. Lastly, they're much more used to messy, unstructured data that may take a lot of different forms. The data analyst and data scientist playbooks don't include building production systems. Here we cue data engineering. In the context of data pipelines, data engineers have both an understanding of software engineering as well as data principles. They are often responsible for the infrastructure which both analysts and data scientists use, although that part is sometimes given to software engineers. They build data pipelines that use languages beyond SQL when needed and assess frameworks for the best way, given a context, to move and transform data. Their stakeholders are usually other data team members, and if we're moving into more of the streaming world, efficiency and latency both matter a lot, and data engineers really, really thrive here. So one thing I mentioned I'd like to touch on, which is production systems. What are they exactly? We have these conceptions of applications or websites built by developers, but there are many, many other production systems out there. There are more than just three data titles, and I even threw software engineering into the mix here. All of these titles fit somewhere, somewhere in between what I'll call the big three. Adapting machine learning models to production use cases is a specialty of the machine learning engineer. The analytics engineer has really emerged in the last couple of years as a person who is business adjacent, but also understands the principles of scaling SQL data models with software engineering best practices like version control and testing. The reason the software engineer isn't on the diagram but adjacent because they don't do the thing that all other data titles have in common: transform and analyze data. The engineers are the ones that deal with the production systems where decisions actually happen from data and they influence the organization at large. Hiring all of these people is already a big team. When you start counting, you usually start with one, not seven. So where do you start? But first, to further illustrate the difference between software and data engineers, let's look at their backgrounds. Fresh undergrad graduates looking for a job. Unfortunately, academia hasn't quite caught up with a data engineering major, but I'm going to take Northwestern as an example in comparing the computer science and data science majors, and is close to my heart since that's where I got my master's. Now, many data science curriculums have specializations in AI, data engineering, business analytics, and so on. So, for the purpose of the comparison here, let's not associate it with just the data scientist title. I'd like to read quotes from the Northwestern pages for both majors that I've, consolidated a bit here. Starting with computer science, we have computer science is designed to show students how to approach problems from an algorithmic and systems perspective. Now, moving to the data science major, data science graduates will possess strong understanding and skills in data management, data integration, algorithms, ML, and the list goes on. The word that stood out to me from the computer science major description is systems. Building computational systems later on in the page, they also mention applying to applications more broadly, right? The systems thinking. Now, as for data science, if getting a feel for all of these areas mentioned in the description, this person will have an understanding of both computer science fundamentals as well as the curiosity and questioning of a data analyst. What I mean by this is that the data science major isn't going to have the same understanding just from their education of hardware and systems architecture as a computer science major. It's just not quite as in depth. But the computer science major, on the other hand, won't have the same gut feeling ingrained in them about when to pause, ask questions about data itself, and validate that the data is representing the whole picture and not just a piece of it. As far as the data scientist title goes, this also applies very much for modeling. When to ask questions like, am I even using the right modeling technique? This part specifically isn't really about the system itself, but about the output. And in this case, the output is data. When it comes down to it, a team always starts with one person, right? Not seven. So one person is the first, and sometimes it stays that way for a while. My argument is that the first person you want to hire has to be a jack of all trades and has to have an understanding of systems and data. First, this person needs to know how to build scalable systems. They're going to lay the groundwork for everything that the data team does moving forward. But they need to also know when to make that trade-off between the at-home circuit and the waterproof watch. Most startups do not need waterproof watches yet and probably won't for a couple years. Early companies don't need machine learning customer engagement systems. They just need simple automated emails so the sales team spends less time manually emailing clients. Lastly, this person needs to know how to analyze data, and that curiosity is key here, something that in larger organizations happens really within the analytics engineering or data analyst teams. This person needs to ask questions about data and be able to quickly draw some sort of insight on either decision making or what to do next to make data valuable for other business units, especially when those data analysts are embedded into other teams. From my perspective, the first hire should be a business savvy data engineer. Of course, there are exceptions. If there are companies delivering an ML model as a service, this person might need more deep learning or machine learning or statistical expertise than a data engineer usually has. Speaking generally, data can't be transformed without the infrastructure that houses it, or at least an understanding of the cloud tooling and where to start and which cloud tools to use. There's still setup that has to happen here, and someone needs to set that up. Either you hire a data engineer, or your first hire is going to be doing some data engineering, even if not by name. So you hire this person, and now they're just swamped and need support. So what do you do? Where do most data teams start these days? With a data warehouse, a BI tool, and maybe eventually you want to version and test your LookML, so you transition to dbt, right? You're in a good spot. You're scaling with modern tools. I don't think I've mentioned anything too crazy so far. Consider you just joined Brex back in 2017. And for those that aren't familiar, Brex is a fintech product that has a popular business credit card product. To be clear, I don't have any affiliation with Brex. I've just picked it because it's a newer company that some are familiar with. fintech is super hot right now and has been for a bit, and it's just more relatable than walking through an early team at a larger organization like Bank of America. The BI stack is rarely enough in these cases. In the case of building a credit card product, the success of the entire product is dependent on the decision-making framework of who to approve or deny for a credit card. When you're launching, you don't have years of first-party data. So the decision is likely based on messy and unstructured third-party data from a whole host of other financial service providers. Maybe you do a soft pull and need to interact with APIs to get the information real time, or you collect consumer metadata about their lending behavior on other platforms. Either way, this doesn't fit in the warehouse BI box of solutions. It likely involves getting data from custom APIs, other servers, and likely processing it in near real time to make a decision on whether a credit card should be issued in this particular case or not. We can try to say what I'm describing is use case specific to fintech, and the way I've outlined it, maybe it is. Going into other industries, however, you'll find equally complex problems to solve, whether it be doing computation on the edge in IoT, real-time delivery notifications and estimates in shipping, real-time analytics when in food delivery to know when to go outside, fraud detection in the form of categorizing phishing emails as they come in, or product recommendations in the e-commerce user experience. None of these use cases will be solved by dashboards. I'm never, never, never on the side of overcomplicating a solution for the sake of using new tools or building something cool. But when the use case drives it and the ROI of the time investment and the money investment to build makes sense, and in many industries it does, there has to be some sort of scalable system in place to deliver data when it's needed in a centralized way. At any of these companies, your first data hire and that first jack of all trades is probably a data person. They have some data engineering background, but again, this business savvy data engineer also does analytics and BI and even dabbles in data science because risk and fraud detection models can be extremely complex. And then your company starts doing well, and this person that's swamped, they've delivered so much value and they can finally expand. Requirements grow, you need more people. So you hire another generalist with a similar background, someone that can do a little bit of everything because initially priorities shift so quickly. Then your company finds product market fit, grows 5x, so the data team needs to support 5x the number of requests. And now you're here. You continue down the path of hiring generalists that know the basics of machine learning algorithms, software engineering, SQL, building dashboards, and can execute on any of these fairly quickly. Because, startups move fast, so you have to execute quickly. And earlier, I talked about systems architecture, and that being the specialty of the data engineer when it comes to data platforms as compared to other data roles. Now I'm posing the question, when do you need a specialized data engineer? I'm going to answer this by talking about systems architecture a little bit more broadly. I cannot stress enough how much I think systems architecture is relevant for every professional, tech, data, or operational. For any problem, how do you know when a hacky solution needs to be less hacky or waterproofed? What does hacky even mean? Earlier, I talked about engineering being familiarity with systems architecture and building for scale. What building for scale really comes down to is the relationship between the complexity of a particular processor system and the time it takes to maintain as complexity increases. Building for scale means not having the time it takes to maintain an exponentially more time-intensive system as complexity also increases. This is simply unsustainable for growth. Before we talk about what data engineers do and why they do it, let's talk about what data engineers don't do. But first, even before we do that, look at some job postings out there. This is just a LinkedIn search of a few job postings that I found. I've highlighted a few words here which I don't think anyone listening is going to be surprised about. And you may not see, but the snippets I'll read are DBT, Python, and Scala, data quality monitoring, building data lakes, processing systems, building innovative tools. Now, consolidating this, what I get from these snippets are they will do some traditional analytics in terms of SQL, transformations, and data analysis. To build data quality systems, you have to understand the underlying data. And some data quality tests are out of the box, like checking the percentage of a column that's null, and others are unique to the business, like checking column values or conditions. This is where business knowledge comes into play. In addition to data analysis, the person hired to do this particular role will build tools for team members internally to use. Now, extend on analytics engineering by building the backbone for data modeling and data quality. Provide data scientists and analysts alike the data in one place, very centralized, even if that involves custom integrations or processing that can't be done with a combination of SaaS tools and SQL. So now on to for what's missing in these posts and what data engineers don't do. First, data engineers don't build things for the sake of building. The tooling landscape is evolving, and there's no need to replace service providers like Fivetran or more recently Portable with homegrown ETL pipelines. There was a popular post circulated about 5 years ago titled "The Downfall of the Data Engineer" by Max Bushman, the creator of Airflow. I believe people working around data engineering and the role's inefficiency stems from not adapting to the tooling landscape fast enough and working too much like software engineers. Data engineers need to be agile, iterative, and sometimes even hacky when an analyst just needs an answer to a business question quickly. When there's a business need for a process to scale, that's when system design comes into play. Second, data engineers aren't just bug squashers. Sure, optimization is part of the role, but not without reason. There are probably few people that care about the time it takes for a process that runs once a day to finish if it's all under a couple of minutes. Lastly, data engineers, they're not just box checkers. While they aren't as close to the business as data analysts, data engineers need to understand how what they build is being used. If it's not used, why was it built in the first place? And if it is used improperly, why was there miscommunication around requirements? Data engineers need to have the same questioning, skepticism, and curiosity that data analysts have to ensure projects result in the right solutions being built. Getting right to it, so what do data engineers do if it's not any of those other things that I mentioned? Data engineers are user-facing, just like everyone else in analytics. The users are just internal stakeholders and analysts. With data engineers behind them, analysts can actually suggest decisions based on data without dealing with a potential mess underneath. Part of that efficiency means often forgetting data engineering exists, just like we don't constantly think about electricity. Everything should just work. Lastly, data engineers straddle the technical and business sides of an organization. They build systems, understand how they're used, and enable others to use them, but don't necessarily have all of the business context to make decisions driving the business themselves. All of these things have one thing in common. They allow people to do the jobs they're uniquely positioned to do without worrying how to get the data when they need to be efficient. If you don't already have a data engineer, that can work for many businesses, especially ones that are SaaS heavy as opposed to build heavy. However, each model has its limits. My rule of thumb is to bring on your first data engineer with the analytics team at large, as when the analytics team is spending over 20% of their time maintaining existing systems. That means the systems can either be built better or more relevant tooling can be brought in. And having a dedicated person to figure that out is going to benefit the organization. Additionally, businesses need data engineers when ETL need extends beyond just SQL and structured data. Now, companies like Portable are building custom ETL solutions for clients, but sometimes the job either has to be done internally or the ETL needs to happen between two first-party systems. Data engineers are the ones moving the needle on these projects, centralizing all data analysts and business stakeholders centralizing everything that they need to get a full picture of the business. At the end of the day, data engineers are there to save others time and reduce data errors. This combination means saving the organization money and setting up for efficient and data-driven growth. Wrapping up, I'd like to leave you with a few things. Examine the parts of your business that rely on data but are hitting technical capacity. Data engineers should enable others to move faster and more reliably. In a similar vein, data engineering work should be high leverage. Usually working on the tiny gains means you're breaking the 80-20 rule. Lastly, everyone should be thinking about systems architecture, both in analytics and outside in an operational capacity. This leads me to mentioning my next venture, Versionable, where our goal is to make systems thinking and observability accessible to all operational teams building complex automations in any SaaS tool that you can think of. Feel free to reach out anytime, and it's my pleasure being part of Summer Community Days, and find me in the OA Club Slack for any questions. Thank you.